Project Datum Vectorization is a 5-year project underway to digitize and standardize the records from old raster scanned maps into a digital intelligent system within NetMAP. The first area to be completed will be Kings Lynn in April 2024. The conversion will gradually snake down the EPN region, completing in Borehamwood in early 2026. This video has been designed for users of the EPN NetMAP Viewer application, aimed at individuals that mainly view and print. If you want to understand these changes within NetMAP core application, please refer to the other video. The NetMAP Viewer will be seeing the same data as in the core application. Firstly, it's important to indicate that the NetMAP Viewer has not changed. Vectorization has enabled us to utilize and unlock functionality that was just not possible with the scanned maps. Please note that this is not intended to be a training-specific video. Firstly, we will look at the converted cables. The old raster maps often showed one or more cables, shown as just one single line, and you would have needed to refer to the cross-sections to see how many cables could be in the footway or road. This was commonly referred to as single-line representation. When all cables are shown on the map base, we call this multi-line representation, and this is what we have done in the converted areas. You will see all cables. Of course, the immediate thing you notice is now all the cables are easily distinguishable, with an identifiable style and color. A point to note is that cables may be shown side by side for clarity, but this doesn't mean they are like this in the ground. Always check for any cross-sections to see the actual arrangement. Here, we can see how it is actually laid out underground, with cables on top of each other, rather than all side by side. Don't assume the map shows the actual position in the ground. Always refer to cross-sections where available. One of the benefits of having vector data means we can make things much clearer than the scanned maps. Styles are much easier to modify in the system. We've made the abandoned cables much easier to distinguish from the live cables. If the cables that are permanently disconnected and are indicated as abandoned, you will see the line style has been changed to display as a thin black line. Cables that have the potential to be used again, or are not yet energized, still look the same as an in-use live cable. Ducts are now shown differently to how we have traditionally represented them. This was done to make things cleaner on the map. Rather than the dashed areas around the cables that were shown before, we have substituted this with cup-like symbols at the start and end point of each duct. This has been done for clarity reasons and to align with best practice in the SPN region. When there are ducts longer than 100 meters, you will see annotation along the cable stating that they are in ducts. If you select a duct in the map, the duct editor specifies the number of ducts and the number of free ducts available. You will also see the type, as well as the length of duct. We now show a service to every property. Services shown as a dashed line are logical services. Logical services have been added to enable customer connectivity. The position of logical services do not reflect the actual position. They take the most direct route from the cable or pole to the property. At the moment, it is not possible to hide logical services in the viewer, but we are working on a change that will make this possible in the future, so you choose if you want to see them or not. Services that are shown as a solid line are recorded routes based on existing information or from the service cards and are the accurate route of the service. You can also have services that are part logical and part recorded, where we know some of the information, but not the entire route. At some point we will change the color of the services to a cyan color, and the style of the supply point to a cross. This will align it with SPN and LPN. MPAN numbers are now stored in NetMAP. Access is from the supply point. Supply points are where the service terminates in the property. As well as providing the attribute information, you can also gain access to the MPAN number. In the supply point editor, select the joined record and open MPAN editor. Properties with more than one MPAN will be indicated by the count. Both will be accessible from the editor. You can also search by MPAN in the viewer searches. Access through Find. Change the category. Enter the MPAN number and search. A welcome addition to the NetMAP overhead data is that we have added the overhead switch and fuse site names. By doing this, means we can maintain a greater alignment with ADMS, and it allows these sites to all become searchable within the data, making it much easier for someone to locate too. For connectivity and tracing reasons, the switches and fuses have been captured on the overhead line that it is connected to, placed 4 meters away from the pole for clarity. Each switch is indicated by a triangle. A filled triangle indicates the switch is closed, whilst a clear triangle indicates the switch is open. Vectorization has meant that as well as getting rid of the scanned maps, that we were able to move away from supplemental sheets that contained the cross-sections, cable designations and enlargements. Cross-sections still remain, but each one is within and viewed in its own internal world. Because we have removed the supplemental sheets that contained the enlargements, we have converted all of that enlargement detail onto the map base. You now do not have to go looking elsewhere for that enlargement information. We now show many more details inside the area of the substation. Remember that not all substations previously had enlargements. We have also rationalized dimensions around busy areas to reduce clutter on the map base. When you provide red line drawings for updates, please remember that you must still include dimensions, so we can accurately capture changes in NetMAP. With the removal of the supplemental sheets, this has taken away the traditional way of following HV routes. We no longer have HV numbers, and whilst this may seem controversial, we do have an alternative and improved way to display this information. Before we explain, we probably need to examine the reason HV numbers existed in the scanned maps. It goes back to a time before everything was scanned, when the maps were on single sheets, hanging in a cabinet. As we have already spoken about, cables may have been captured in single line representation. Each sheet would tell you where the cable went to and from, giving it an identifying number. This number could be followed along the route, through cross-sections and across map sheets. There is no need to do this anymore. We have moved away from having separate map sheets, and as already covered, we now display all cables. This makes following routes much easier, not just visually, but now you can trace cable routes. We will cover cable traces further on in this video. As well as showing all the cables, we have also introduced an HV diagram that enables you to follow all HVs in a geoschematic way. By switching to the HV diagram theme, you get to see all the HV routes, underground and overhead. It gives you that, at a glance view of where routes go. In NetMAP, these are known as HV circuits. These HV circuits are not as you would electrically recognize them, but instead run between either a site to site, or a site to T, and thus replicating the HV sections you can see in ADMS. If you select one of these HV circuits, you will be presented with information in the editor, the number of sections of HV cables, number of HV joints, or the number of sections of HV overhead line within that HV circuit. You can also see the start and end node. This indicates where the HV circuit route starts and ends. This is the replacement for HV designations that used to be in the supplemental. Each cable, joint or line within that circuit is listed at the bottom of the editor in the child objects. You can see in the example that this HV circuit contains 3 cables and 2 joints. From here you can open the individual cable editors if you wish. The length of this HV circuit is 296 meters long. It starts at Oxborough Drive substation and ends at an HV branch joint. The branch joint number is taken from the T-point alias you can find in ADMS. HV overhead circuits will usually tell you that the start and end points are at pole transformers or at poles. This overhead example starts at HV pole 624128 and ends at HV pole 624122. If you have already looked in detail at substations in NetMAP, you may have spotted that each site contains an internal world. To begin with, we must point out these are not enlargements. They have been created mainly for the purposes of customer connectivity and network tracing. Each internal substation has an HV side, intended to replicate the normal operating conditions in ADMS. You can see NetMAP displays open or closed HV switches differently. If you were in a NetMAP design, you could choose to change the switch state to see how that might alter the network. We will cover network traces in the next section. On the LV side of the substation, fuses are indicated in or out. These can also be changed in a design. Equipment editors in the internal world also hold the SAP functional location number. NetMAP has 2 other objects with internal worlds, link boxes and feeder pillars. Here you can see an example of a 4-way link box with its fuses and LV busbar. Way 81 and 84 has the fuses out, and 82 and 83, the fuses are in. As you can see, the link box internal may tell you where the cable runs to. When the cable records are completely vectorized, it makes tracing networks much easier to do, using the tools available to you in NetMAP. Tracing has not been fully set up in the NetMAP Viewer yet. We need the business to tell us what type of tracing functionality they want. There is much more possible than what you will see here. The first trace allows you to select a service and find out the substation that supplies it and all the connected services on that feeder. The second trace traces out to the LV switching point. You can see that it has stopped at the link box, where there is an open point present. What we are going to do next is trace out from a site to a set distance along the cable route. In this case 15 meters from an LV connecting node. We have a substation site that is already prepared. We have selected the LV fault location and added 15 meters to the distance. You can see that the trace highlights 15 meters from the start point, on which might be a faulty service joint. Whilst we are confident that the conversion of the scanned data into a vectorized format has been done to a high standard and has gone through rigorous quality checks, there is always potential for some minor errors or for something to be missed. That's why we have an archive version of NetMAP to store all the old scanned maps cross-sections and enlargements. If there is something that you want us to check, then contact the Geospatial Network Records team, and we will access the archive system on your behalf, and send you any details you want to see. We hope you have found this video informative.